you think, Andy? Shall we start? So it looks like
Yeah.
those who wanted to come have come. And I'm very glad to greet all our participants and announce our speaker. Today's speaker is Andy Rivkin from the Freie Universität Bolzano. And we continue our topic on Petri net extensions. And now the talk will concern Petri nets with data. And it's always a challenge, though there are different approaches, different ways to extend this formalism, but still there are questions, and for different areas, for different applications, we do need different extensions, different perspectives for looking at it. So, Andy, you're welcome. So,
thank you very much.
Good to hear you. Yeah.
Thanks a lot for the introduction. So, hi everyone. I think it's needless to repeat the title of this presentation, and probably before starting, I would actually like to say thanks to the co-authors of let's say long-lasting collaboration research that we're having already before, and this work is actually one of the fruits of this collaboration, and it shows how to bring also sophisticated techniques which are present in the domain of formal verification, model checking, to, let's say, more applied domains like business process modeling, and specifically modeling of processes with data and correlating objects. So let me start with a simple example, although here probably this scheme could look a little bit cumbersome, but so this is a classical example of an order to delivery process. So usually you kind of have a few steps starting from, I don't know, ordering something, right? So to order something, you need to create your order. Then you could actually probably even think of it as an order that you're managing on some e-commerce website. So for some of you, for example, Amazon would be a good example. For others, I don't really know what else could it be. But so here, let's say we started by creating an order, like opening your shopping cart, and you can just continue adding items. So I'm presenting here probably the happiest path, right? So when you just only add items and you don't remove them, then as soon as you're done, you're saying, okay, so I want to check out and I want to pay it. You're paying your order, and it can actually happen that certain items will be dispatched at different times, right? So that's kind of happening in the background of the logistics unit of the website that is processing the order. So you're essentially going to have probably some of your items put in different packages, dispatched at different times, and all these items will be sent, the packages will be sent, and they will eventually arrive to you. So this is a very kind of generic thing. However, I would like to put your attention to a few things here. So when we want to deal with this process, right, when we want to, I don't know, correctly implement it, when we want to correctly formalize it somewhere, we have to put attention to the next component. So we're dealing here with different objects. So we can, for example, think of objects like order, right, our shopping cart. Items are also objects. Packages are also objects. And moreover, when we're talking about these objects, we also need to think about how these objects relate to each other. So for example, here, like packages and items are in many-to-many relationship with each other. Then another thing is that we're actually also dealing with the data here. So when you are trying to add an item to your shopping cart, it can happen that before doing it, there is a query ran on the background that is actually checking the availability of this item in the warehouse. So that means that you need to access the warehouse database, and you need to check, so that the website checks whether the item is available there. It is going to tell you, okay, the item is available, and only after then this addition operation will be completed successfully. Same applies to processing your purchase, because, for example, if there was a limited amount of items available in the warehouse, and probably someone else in parallel with you was also ordering these items, and that person was faster, then what can happen is that the desired amount of items is not going to be available anymore at the checkout time. So all this kind of data checks are important to be done. And another actually interesting thing here are also resources, right? Sometimes also complex. So for example, here, when we want to dispatch something, it's not that simply we just say, okay, we put our items in various packages, we load those packages on the trucks, and the trucks are sent away. No, we need actually to check whether trucks are also available, what are the what are the most optimal variants currently available, and so on and so forth. So I hope I managed to give you a rough picture of what are the, let's say, complications within the different scenarios, process scenarios that we sometimes need to deal with, and we need to deal with them when we want to actually formalize, because why we want to formalize, essentially to understand better how our model works, because like that we're going to have this kind of falcon bird eye view over the whole system. And as a matter of fact, this formalization is strictly linked to, let's say, an old problem that is called the data and process dichotomy problem, in which many scientists try to propose, so to say, balanced solutions, in which they try to find a good interplay between data and processes. And as a matter of fact, when you're trying to mix in your solution different ingredients, you usually have to choose from a plethora of things. Like on the data side, you would look into relational databases, artifacts. You would try to think, okay, how do you represent my objects? Well, probably with identifiers, so maybe I add something else. Then like for the, actually for the topic of the seminars, you would also talk about Petronets, and in Petronets you would use colored tokens, I don't know. And on the process side, so for the sequence of activities, right, which are performed with a new process, you could use some front-end languages like BPMN or UML activity diagrams, or again, you could use Petronets. So in this, let's say in this presentation, I'm talking about one of those solutions, which is called catalog and object-aware nets, in which we, let's say, add a few dashes of objects with identifiers, right? Object identifiers on the data side, right? Typed case data, and also read-only database, which we call here catalog. And on the process side, we are dealing with a high-level Petronet, or probably it would be even easier to say just colored Petronet with an ability to manage fresh name generation. So let's start, let's say, with the first part of this presentation, which is the formalism. I'm not going to talk about the formalism in detail, so giving formal details of it, but I'll try to provide the most interesting modeling highlights. So let's start with the places, right? So I'm pretty much sure that all of you are aware of Petronets, and that I don't really need to give a definition here. So here we are dealing with colored places, which maintain typed case data. And so what are the data types? So each data type is having a potentially infinite value domain, and it's equipped just with an equality predicate. So essentially, we cannot really perform any fancy things with elements coming from those value domains. And another thing that we can, of course, do is merging those data types using the Cartesian product. Obviously, you can immediately see that places somehow represent states of objects that we're dealing here. So you remember there was the order object. And what we can have here is just the simple net, for example, which is representing an object life cycle. So we are just moving from state working to paid, right? And that actually shows the real evolution of an order object. Now, another thing here is, as I mentioned already before, is an ability to generate fresh data. And this is done using new variables. That was a feature introduced. Well, I was actually told that it was also used in other domains, but I got to know it personally from the 2008 paper by Rosa Velardo and Frutas Esric about name creation versus replication of Petronet systems. So this is essentially a feature that is provided by those special variables, those new variables. So here we have new O variable that allows you always to generate unique order identifiers. So those order identifiers are going to be, so to say, locally maybe unique because they're going to be local to the marking that you have. So in the current marking, the value that this new is going to provide is always going to be different from all other values available. So now another thing is the catalog. Probably you all know relational databases, and the catalog is essentially a bunch of tables with two types of constraints. So we are having primary keys. So and we actually enforce that every fact in every table is having a unique identifier, right? So a primary key. And relations or tables can be related also using foreign keys. So with the foreign key, we have a little bit of a special treatment. So we say that a table references another table, and the child table that references the parent table should have as the foreign key attribute something that is not a primary key attribute, right? So this is described in this third bullet point on the slides. And yeah, and an important thing is that types, obviously, of these columns of the attributes have to coincide. This thing that will be, let's say, evident later on, or maybe just, it's important to mention that one may think that this restriction is a little bit bizarre, but this is necessary for the verification technique that we're using here. And we've shown also in other works that, let's say, given the current machinery, meaning the theoretical machinery, this is probably the most sophisticated setup that you can afford. Now, let's talk about how transitions can manipulate the tokens flowing in the net. So we, for that, have transition guards, which essentially consist of two components. So we're having one component that is classical filter. This is the thing that you're having in colored Petronets, right? So you just filter your flow. That is the phi. And we also have a query queue, which is allowing us to query the catalog and possibly inject data into the net using the results returned by that query. So in this example, we are having this kind of small net excerpt that is showing a guard, which has a query that is querying the catalog of products. And it's saying, so give me all the types of products that are available in the catalog apart from alcohol type. So we are going to take everything from there apart from alcohol. And then the value that we're going to get, we're going to put into variable P, right? So this query also allows us to do the injection of values. Right, so now the favorite thing of everyone who does Petrinets is to play token game, right? So let's play a token game and see how does the model actually work here, all right? So this is, again, just a part of this order to deliver example that I showed you in the beginning. And we're starting it by having, let's say, our catalog populated with certain product types, product categories like books, kitchen, fish, right? So we just know the types of those. And we're also having another table that is called product truck compatibility that tells us which products can be moved by which trucks. So we have trucks, like we have a truck with a plate number that is actually provided in the place in-house. So this is the only valid place here, with the plate number T52YN. And this is a truck of type refrigerated truck. And we're having another one, which is a box truck. And the table, this product type compatibility, essentially shows the compatibility by the truck type with the product types that are available here. So how do we start, right? So you see that we only have tokens in this, let's say, place in-house, but we don't have other tokens. What we do, we actually start creating orders, right? So we generate them. We're generating down a new order with the order identifier O233. So we generated a token, all good. Now we're generating another order. So imagine like someone else probably entered the website and created another card. So now we're having two. And now we're deciding to add a product to the order with number 45, right? So for that, we need to fire the add item transition. But when we're firing it, we have to query our database, right? So we're querying our database. We're getting as an answer set all the product types which are available in it currently. So I removed here that filter with alcohol, so to make it actually more readable. And well, let's say that from all the types that we have here, we're choosing the fish type, right? So we're saying, okay, fine, let's pick up a fish and add the fish to our shopping cart. So we have now a fish added there. Okay, so what do we do next? We say, okay, fine, let's add another fish. So we're taking two fishes now. And then we decide that it's time to pay probably. Well, two fishes are enough. So we paid our order. And now, as soon as we paid it, what we can do, we actually can proceed with loading it on the truck, right? So we start loading the order on the truck. What do we do for it? We fire this load transition. So this one is a little bit different from the previous one. So here we don't really populate the data, but here we do this kind of matching. So we know that we have the fish, and we need now to understand whether we actually have this product type compatibility even available. We see that it's available. So for fish products, we need to have refrigerated trucks. So what do we do with that? We also check that in our in-house place, we have a refrigerated truck available. We say, okay, well, that is great. So now we can assign this fish to that refrigerated truck. So we are preparing somehow our order. It's not yet being fully dispatched. And well, we obviously could have done it with another one, but let's say we're not playing here Stanislavski, and thus not all the transitions that I have here should fire. So let's probably proceed with slightly more interesting things, which are different modeling features of this formalism of catalog and object-aware nets. So yeah, here, let's say three most important highlights, at least what I think is important here. So first of all, I already showed you in the first page of the formalism presentation that we can model object life cycles, right? So this is pretty much straightforward, and probably I don't really think we really need to elaborate much on that. The second one, however, is on-the-fly object creation. So this one is more interesting because you've seen already that I can create orders using those special new variables, right? So those are going to be always unique orders that I generate. But also, I can do other things, right? So I can do creation of objects which are involved into one-to-many relationship. And this is going to be the creation of objects which are staying on the many side, right? So, so if you think order and item, right, as classes, as entities, are in this one-to-many relationship. Thus, items could be actually created as soon as I'm having an order object provided, and you'll see it in a bit. Actually, we've already seen it when I showed you sample run of the net. And then, of course, there can be also the catalog-based creation. And the last, but not the least feature, I think, modeling feature of our formalism is the object synchronization. And let me show you now on, let's say, this complete model of the order to deliver process. So let's look into these features, right? So this unbounded creation of orders using the fresh identifiers is essentially done by this part that is highlighted in currently highlighted in the model. Then there comes this interesting part when you can create objects which are in relationship. So here you can create items using the catalog, right? So you're getting the data from the catalog, that was the item type, and identifiers of owning orders, right? So you always need to know the owning order. And like that, you've also seen it. You can add multiple items with the same product type, which are referencing the same order, right? So we had 2 items of fish there. And in this particular example, it is not really needed to track the evolution of items. And for that, you don't really need to have an explicit identifier, right? And so one, of course, can argue, why don't we really track the evolution of items? So our take on it is that items should not be tracked because they are never involved on this one side of some one-to-many relation, right? There is actually also another thing about relating items and now trucks, right? So here we use trucks as is probably a shortcut. So we could have probably put them in packages first, in boxes, and then putting those boxes on trucks. But here we just immediately relate them like that. And when we relate them, the item, right, is going to reference plate number of a truck, which is the truck's identifier. Now, okay, so this was probably wrong slide. Now, another thing is, right, I beg your pardon. So that was just to conclude that this thing that I discussed previously can be actually seen as the pattern for creating objects which are in this one-to-many relation. Okay, so now another thing, you remember that I was mentioning in the very beginning of the presentation, the resources. So here we're dealing with trucks, and trucks essentially are resources here, right? So we have trucks available in that pool place, right? So we have a fixed number of those. These trucks can change their state, and also they cannot be destroyed. So probably one could also look into the resources that are consumable. But I think the main message here is that you can model really complex resources and also play some synchronization game with them. Last thing here is the non-deterministic synchronization, right? So I'm calling here non-deterministic synchronization, but probably those of you who attended the previous presentation by Dirk, which was on proclets, this I think fits one of the patterns that Dirk is having. So I'm going also to comment on it later on, which allows you to synchronize some subset of child objects with a parent object. So here we actually have items synchronizing with a reference truck, and we are doing it here, so to say, non-deterministically, because we do not really guarantee that all the items will be put on the truck that they are assigned to, simply because the truck can just go back, right, and drop the whole synchronization thing. Right. So now we are done with modeling. Probably, if you have questions about it or some comments, we could discuss it right now, because I think we are pretty good time-wise. So if there are no questions right now, probably we can go on with the verification. Right. So there were no messages, anything like that. Oh, there was something in the chat. All right. Okay. All good. So verification. Let's again come a bit back to the verification of data-aware processes. So that was, let's say, this kind of concept that I was mentioning in the beginning. So when we try to do the verification of data-aware processes, we always need not only to consider the evolution of processes, but also look into the causes and effects that the processes induce on the data that we're having in our scenario. And for that, it's very important to choose well the components of the framework that we are dealing with. And here, so our idea was that, okay, so which components shall we choose? So can we allow more flexibility on the verification side, right? So what if we can be parameterizable with respect to some data components in our model? And we also try to look into the recent verification results for data-aware processes, and also actually including the verification results that we're having here. And we basically decided to have those components that you've seen in the beginning. So I was saying that, for example, having this read-only catalog, which at the beginning can look as something maybe not very efficient, is something that is essentially supported by the verification setup that we're having here. So obviously, when you want to do the verification of catalog and object-aware nets, you obviously have to bear in mind that these nets have different sources of infinity and unboundedness, obviously. And as soon as we see those things, we always think, okay, so how do I verify it? And let's say there are powerful tools to do it, and we're using MCMT. Let's say it's an SMT-based model checker for array-based systems, but not only the model checker, the whole theory behind it, which is actually also called MCMT, so modulo checking modulo theories, model checking modulo theories. So MCMT supports parameterized verification of data and processes, parameterized with respect to the data. And in our case, we're doing this parameterization with respect to the catalog, and obviously not the marking. And the catalog is having a fixed signature. So we need to say, okay, we have that many relations. These are the foreign keys. These are the primary keys. And for that one, we can do the parameterized verification. So then essentially the question that we are interested here, the verification question that we're asking ourselves, asking ourselves and asking when we have the models, is my process going to respect given quality conditions no matter the kind of catalog it runs on, right? So to answer this question, we basically perform 3 steps. So the first step, we directly encode market catalog and object-aware net into a database-driven MCMT specification. I wrote here that there are certain technical limitations, and these technical limitations are, well, it's basically one technical limitation. So MCMT as the tool can encode currently catalog and object-aware nets in which each transition manipulates at most 2 unbounded places and possibly arbitrary many bounded places. So this thing, however, is not really a limitation, because we know that any conet can be transformed into a net with this property from above, right? So the property with which we say that we just have 2 unbounded places and as many bounded places as you want around one transition. Then, as soon as we are done with the translation, so we're having our MCMT specification, we need to define the property, right? The data-aware undesired coverability property that is composed of catalog queries and special predicates over places, right? So on those properties, the predicates in those properties are those which check whether a place has at least n tokens, or at least n tokens of some value, right? So you can immediately already see that this is essentially a coverability check that we're performing. And there is, let's say, also a restriction on the catalog queries. So that says that all the variables that you have in these relations, right, that you have in your catalog query, have to coincide with those that have been mentioned in the predicates used in your property. So here's an example of a property that is the order to deliver net can have a configuration corresponding to a situation in which a delivery occurs for an item for a not yet paid order, right? And this property can be specified just as follows. So you just have these 2 places, delivered and working, and you consider that both of them are having at least 1 token in them, right? Now, the next thing, the last thing to do, right, as soon as we have the property and the encoding done, is actually to run the MCMT. So what does MCMT do, the tool, right? So it does the safety analysis using a backward reachability procedure that here I just call it BREACH, right, for simplicity. And this procedure will run over all possible instances of the catalog that we're having here. All right, so probably I think now it's interesting to look maybe in some properties of this backward reachability procedure. So, well, we call them meta properties. So there are essentially three of those. So the soundness, that says that whenever backward reachability terminates, it produces a correct answer. Then partial soundness, that says that the result returned by this backward reachability, a safe result returned, is always correct. And completeness with respect to unsafety, that says that whenever the net is unsafe with respect to some property, then the backward reachability algorithm detects it and returns unsafe. So you see, now I'm not talking at all about decidability and undecidability. So I'm looking into those things because well, you will see now these things, right? So how can we, let's say, map these properties on, sorry, here I'm actually having a typo. I'm calling it catalog nets, right? That should be coanets. So how can we devise, how can we map these results for different variants, to different variants of the coanets? So when we're dealing with, let's say, fully powerful catalog and object-aware nets, we know that the backward reachability is partially sound and complete. When we're dealing with conservative coanets, the conservative coanets are those which have no new variables, right? So you cannot really create fresh data. Then the backward reachability is sound and complete. And one problem I wonder, so how do we manage missing new variables, right? So to deal with it, there are three ways. So first and foremost, new variables should be avoided when you're not dealing with the one side of one-to-one or one-to-many relations, right? So objects which are involved in one-to-one or one-to-many relation. Another way to deal with new variables, which probably also comes to one's mind, is fixing objects a priori in the initial marking and doing, let's say, the analysis of bounded number of cases, right? So say, okay, we fix n objects and we do n cases in isolation. But there is another feature that is somehow the mixture of what we have in catalog nets and what the backward reachability allows us to do, is the pre-creation of objects in the catalog using catalog-based emitters. So what is the thing here? The main idea is that a run with unique identifiers is guaranteed to be explored by a backward reachability procedure. So among some of the runs that we're exploring, there's going to be one in which all the objects we wanted to generate are going to have unique identifiers. So this is let's say, a very interesting observation here. And then, of course, there is a variant that is bounded for a given bound, right? So conservative catalog and object-aware net with an acyclic catalog. So in an acyclic catalog, tables can't directly or indirectly refer to themselves using the foreign keys. And for this case, the safety checking problem is decidable. So again, there are probably a few recommendations what one could do when you're dealing with this bounded conservative catalog and object-aware nets, right? So how to make them bounded? You could compile away the new variables and provide fresh values in the initial marking, right? So that's pretty much the way it was done also in the previous case, one of the recommendations. Then you need to introduce additional resource places to control the evolution of certain objects. And you could add a bound to the many side for objects which are involved into one-to-many relationship. So this is the way how you can ensure and deal with boundedness in this case. Right, so there's probably an observation for those who would be still wondering, okay, but what are probably the decidability boundaries for this model, right? Because it's quite common to talk about just decidability and undecidability cases and not really much to look into the semi-decision procedures, like the one of backward reachability. So question here is, what is worse, doing parameterized verification or having the formalism that is having that expressive power, right? So having this tuples of different object identifiers or other values, having catalog queries and so on and so forth. So turns out that it's actually enough not even to consider the catalog, so consider only objects. And well, we are calling it just object-aware nets. And there is, let's say, a very interesting passage, again coming to the work by Rosa Velardo, which shows that coverability is decidable for new Petri nets. And what are new Petri nets? Are essentially object-aware nets with unary places. So unary places meaning that you basically cut away also the Cartesian product feature of catalog nets. And a single data type, so consider strings. But what happens if you're saying, okay, so I'm bringing back the Cartesian product, and now I have pairs in my places. So let's call them binary places, right? And as soon as you introduce it, your model becomes immediately Turing complete. So verifying place non-emptiness, for example, for object-aware nets, which is essentially coverability test with only two binary places and other one bounded untyped places is undecidable. And this can be shown by reduction from the halting problem for Minsky two-counter machines. Okay, so now I'm coming to, let's say, the last section of this presentation that is comparing, well, not even comparing, but showing how catalog nets could relate to some of the models. And actually, two of those that I'm going to present are also appearing during this seminar series. So this is the model that is not appearing here. So the model of DBNets that I co-authored together with Marco. So in DBNets, what you have, you basically take your catalog and object-aware net, and you add also a possibility to have read-write relational database with the full package of integrity constraints. You're also having places that provide you some sort of materialized views over that database using the full power of SQL. You also have rollback arcs, but yeah, these are you know, like multiple different features that are available there. So if someone is interested, you could look up in the papers which are mentioned here. But the thing there is that we have only results on the theoretical verification using finest state abstraction. So we, let's say, never experienced it in practice. So this is probably something that has to be done, but yeah. So how does it compare to catalog and object-aware net? So in catalog and object-aware nets, we don't really have this read-write relational database, but instead we're just having this read-only catalog. However, if you may, you could, well, actually representation of read-write relations is perfectly supported. So to do so, you essentially need to introduce, so to say, relation places in which you're going to put your objects, you're going to remove your objects. It's still going to be, so to say, an under-approximation with respect to the semantics of the DB-nets, because in DB-nets, to represent these kind of updates in a more fragmented setting, like so, because in DB-nets, all the updates over the database happen atomically in one transition, right? So if I transition does not only consume and produce tokens, but it also updates your relational storage. Here, to represent this thing, you would need to introduce transitions with priorities, which is not available. So does this kind of updates, like deleting facts, adding facts, is going to happen in a lossy way. However, again, so probably for coverability tests, it does not make much difference, because you are eventually going to explore a run in which you added and removed everything you wanted. Now, another thing here is that we're not really full SQL, so we're using union of conjunctive queries with atomic negation. And yeah, so this is probably not as strong as SQL, but this is pretty much enough. And of course, what we are definitely stronger than DB-nets is on the verification side, because here we have a tool support. Another thing, so I guess probably Jan-Martijn is going to talk more about it. So this is the ISML. And basically, we could probably compare this catalog and object-aware nets to the control flow layer of this ISML framework. So it's information systems modeling language. So there, probably at the control level, we are pretty much the same, apart from the data manipulation. So data manipulation, I mean that here we read from the catalog, whereas in the ISML, you can work with this conceptual data model via ORM. So it's way more powerful and way more expressive. If I'm not mistaken, there is the bounded number of objects in the net, right? Right. Okay. So I see you nodding. So this is let's say the difference that we have, because in catalog and object-aware nets we can support also this the generation of unboundedly many objects. And I think also probably the focuses that we are having are slightly different. But I think, well, I hope, Jan-Martijn, you're going to tell us a lot about it in a week, right? So, okay, I probably skipped this part now. So, and I move to the next one, that is the model which was presented during the first seminar, during the first session of the series of seminars. That was the model of Proclets. So probably, as you remember, so those who attended, the features in Proclets were that you could essentially have this sophisticated correlation mechanisms to say when objects that have, say, their life cycles defined can synchronize. And this, let's say, this correlation was done also implicitly. And when you had to deal with objects, right? So thinking about them in terms of tokens, you basically had one initial entry point for generating all these objects, and that had to be done once, right? So you generated them, now you have the fixed set of them. and then you just go on in your life cycles, and then whenever you need to synchronize, you synchronize. So in our case, as you've seen already, the creation of objects is done asynchronously. So you create them whenever you have it supported by your model, right? So if you've foreseen by your design that here at this particular spot you would like to create new objects, you're going to do it, right? And then of course the correlation can happen at any time. So well, there is the correlation that as you've seen is actually captured with the reification, right? So we basically represent our tokens as, so to say, relations, and we put our identifiers into them, and then we just do the checks or joins on transitions when we fire them, and thus based on that we do the synchronization. And actually another thing which we also looked into is that we can simulate with this catalog and object aware nets some of this synchronization mechanisms that Dirk is having in Proclets. That is the subset, I think. Right. Yeah, right. So the subset, because there we can essentially have this non-deterministic synchronization by like having a lock and then putting in the lock, then synchronizing some things that we want, and then releasing the lock, and then the synchronization is over. And unfortunately, what we cannot support the equal synchronization, because for that we would need to introduce so-called whole place operations, right? And this is something that we currently do not support, also for the reasons that this is not actually supported by the verification technique that we're having. Right, now I'm coming to the conclusions. So maybe a couple of takeaways here. So for just to round it up, I showed, let's say, various modeling features that resonate, let's say, with some of the state-of-the-art PetroNet-based frameworks, which are used for modeling and reasoning about data-aware processes. And also, let's say, what we support in our modeling, I think this is very important, is this ability to check parameterizable covariability. This can be used for different fragments of this CONETs, and we provide the support within this MCMT model checker. Yeah, and what I just recently talked about were the connections to other PetroNet-based frameworks. Now, probably a few words on open directions, right? So there are a few of those. There is the one on modeling, and here I think would be very interesting to look into extending the model that we have with various interesting features like whole place operations, as I already mentioned before, and actually seeing what kind of analysis can be done while having this operation, and also probably adding numerical data types and arithmetics, which is an interesting feature indeed. Then on the verification side, so the question that, well, it's probably not even a statement, that's, as I put here, that should be a question. Can we use catalog and object-aware nets as the verification backend? So it's the verification backend for whatever thing, right? So that can be a real tool, right? A real framework, something implemented already that is having a well-defined front-end language, and then you can just basically define the mapping and perform verification tasks. Or it can be used as the verification backend in more theoretical terms, right? So you have your formalisms, and you would like to say, okay, so can I do some verification? So you can always do the comparison between coordinates and the formalism at hand. And another interesting thing probably is to study more, let's say, classical properties, especially for nets which are used to model business processes, properties like soundness. Maybe if something else comes to your mind, I would be actually really happy to discuss it. Then application, so probably it a bit touches the first thing that I said for the previous direction, for the verification direction. So what are the possible applications, relations with existing front-end languages, right? So this is something that would be very interesting to discover, to study. Then, of course, to show how fast can we perform our coverability checks, it would be important to have a benchmark. And if I'm not mistaken, the benchmark is basically, well, benchmarks for data-aware processes, the sore spot, right? So you don't really have many or any, I would even say so. And so I think there probably should be some effort put by a group of researchers or even by the community to push this thing forward, because I think many of us will benefit from it. And the last thing is, well, that's probably nothing surprising, is the tool support, in the sense that we don't really have any modeling tools. So writing specifications by hand in the model checker is very painful. So some front-end UI is always a great thing to have. So that's a thing that we're currently keeping in mind. But if you have something to add here, I'll be glad to hear it. So I think I'm done. And thanks a lot for your attention.
Thank you very much, Andrei. So it was really a very interesting talk, and also so just it was very interesting that you so just connected it with the previous talk by Dirk and with the next in a week talk by Jan Martin. So just it's really becomes a very interesting event, I guess. And then so just many questions, discussions. So you can do it both.
There are a couple of questions in chat. So from Anna Voloshka, maybe you will.
Yeah, if you'd like to unmute and ask it in person, that would be better. Otherwise, I can just read it.
Anna, would you like to ask your questions aloud?
Hello, everyone. Thank you very much. Thank you for your presentation. It's really, really interesting. But can you open the picture with your model, with trucks and so on?
Oh, you mean the full one?
Yes.
Let's look at that, right?
Yes, and the question concerning the violet part about trucks, because we can add some orders in one truck, and how we can show it in the model, that we need to check if the truck has some free space for this order, or it's full, or somehow can we see it on this net?
Yeah, right. So thanks. That's a good one. So essentially, you don't really have any description of the truck, right? So you don't really know what is the capacity of the truck. Checking whether the truck has something in it, right? Or setting up the, I don't know, the boundary for the truck. That would mean also that you need to implement this kind of zero testing in your model. But yeah, that's possible. So probably you could also have a counter in your net implemented already, like just counter as you put 5 tokens and you say that in the truck I can put 5 items max. And of course this is going to be done, the addition of items is going to be done in a lossy way, so to say, because you can you will never well, okay, you will guarantee if you check this property using your model checker, right, using the MCMT model checker, but you will never be able to guarantee in your model. So if your question is about the model only, that you will always, let's say, be able to put 5 elements in the truck. Always 5 elements, right? So you would be able to put probably 1, probably 2, probably 3, probably 4, probably 5. And then you would also need to return this, I don't know, 5 tokens back. But that will mean that either all the trucks need to have the same cap defined for them, or that would mean that I don't know, probably you would need also to have this cap somewhere else defined. So yeah, I hope I actually managed to answer your question.
Thank you very much. And if I can ask one more question.
Yeah.
Also, when you show how you put the fish, can you open this picture?
Sure. So the run, right?
Yeah.
Yeah.
I don't understand exactly. When we have in a ready place 2 items of fish, how we can load them, 1-to-1 or 2 parts in the same time?
No. You're going to do it one by one,
Oh, okay.
right? Because you just have one single arc and you have this PO there, so you bind it to the PO and you just click your sorry, that was load, right? So you load one, then obviously you could load the second one because you still have the truck available in this in-house place. So this the bidirectional arc, so essentially models the read arc here.
Okay, thank you very much. I understand.
Yeah, great.
We have 2 more questions. The first one was from Julio Carrasco.
There was also someone raising a hand there. So.
Yeah. But
that was Julio first. Yeah.
So Julio, please.
Thank you for your presentation, Andrei. Well, my question is very simple. So if you or your team have thoughts of working with this in a process mining setting, or it's a model that it's just to work in the side of model checking, formal verification.
Thanks, Julio. That's a very good question. So process mining. Okay, so which kind of process mining you mean? You mean discovery? You mean conformance checking? What exactly?
Tell me you.
So, well, probably, well, I cannot really say much here about any of those because I think it's also probably a new topic because there have been recently works appearing on discovery on, well, there are already known works on conformance checking of some kind of data-aware classes of Petri nets. So here, look, catalog probably in conformance checking is redundant, right? So you would probably just throw it away and just deal with this OA net, right? So just object aware net. Then you tell me how you want to manipulate the net and how you want to perform the conformance checking task over it. So probably, obviously, I think something can be done also naively, right? Then question is what you have in your logs. Yeah, so you see this is quite a simple net, and it does not require logs in different formats. Like it probably would not require OCL format for logs, because you would not need really to think about this many-to-many correlations, right? Because you would just kind of have everything running in your net, and those correlations would probably appear even implicitly, so to say. Then when it comes to the point of discovery, well, that I really don't know. So that is probably harder, because maybe there you could also discover your catalog, but in the sense that you discover an instance of the catalog. So you know that some kind of the data have been appearing, but that probably depends on the type of the log that you're having. So I don't know about the log formats that could be beneficial for that kind of model. Or maybe you need to do some really unconventional reasoning on top of the log in order to understand what is the catalog, what are the queries that you're running on top of it, and so on and so forth.
I agree that perhaps a good direction could be on conformance. And actually, I feel that there is a gap on conformance checking works that
Working on it.
that cope with the use of global storage, no? So how you do conformance of a model that also is connected with a global storage, like your database, like your catalog.
Yeah, you're right.
Catalog page is always difficult if you want to do conformance, because you never know what is in the catalog if you only have event logs. But for object, so for OA nets, you can do some conformance checking. That's possible. Naively, it is quite simple to implement, but runtime you don't want to know.
I hope you actually are going to say something about this experience during the next, just like
I could add 1 or 2 slides
as a side comment. That would be extremely interesting, especially on the performance side, because I think that indeed those naive techniques are probably somewhat even low-hanging fruits, but I think that on the performance side, it's really a mess.
Yeah, we'll show some of those elements next week.
Oh, great. Thanks, Arnaud.
Thank you, Andrei.
No, thanks, Julio.
Yes. Vadim Denisov has a question. Yes. So.
Yeah. Thank you, Andrei, for the very interesting presentation. I have a question about the slide where you compare Proclet system with your model. You said that in the Proclet system, it's you all.
I go in there.
Yeah, all cases are first created, and then you can.
Yeah, here.
This first point. Initial object generation is performed only once, and you can create object asynchronously. So I didn't completely get it. Or in the Proclet system, it's also if you have transitions with new operator on it, they can run. They can fire anytime, right? What is the difference?
No, so my point here was that probably I should have said that was the init constraint.
Init constraint.
Yeah. So when you do the init, then essentially you would populate one correlation set, right?
Right. Yeah.
So as soon as you're populating one correlation set, you're bounded to work with this one correlation set. If I'm not wrong.
Yeah, maybe the same case when another transition is fired for the same case, it's another correlation set can be created, right? So one case can participate in different correlation sets.
Yes, absolutely. But somehow you are going to work with those correlation sets in isolation, right? Yeah, which is.
Yeah.
So.
Oh yeah, I got what you mean. Yeah.
So here you would in our case you would basically create your objects whenever you want, right? So you would just create them at any point, and whenever you can synchronize them, you will synchronize them. So without really looking into correlation sets, which.
Yeah. Thanks.
It seems that Jan-Martin has something to add.
Well, more an intriguing question. What is verification? Or rather rephrased, what are the properties that we would like to verify if we have such nets? So is classical reachability the proper thing to validate or to verify whether some states are reachable? Or do we have different properties that we want to check now?
Well, the properties that we're supporting, you've seen them, right? So that's basically just a predicate that you have over a place. So you say, okay, how many tokens I have? Well, actually, don't say how many I have. You say, do I have at least that much, right?
Yeah.
But then, and then you can query your catalog. But actually, querying your catalog is a tricky thing, because if you're putting some catalog query in your property, that means that you are also enforcing a priori some data into your catalog, because model checker does not see the catalog at all. So it doesn't have any catalog instances. That's why you're parameterizable. So you can put something in it and say, okay, yeah, I have it inside.
Yeah, but I mean more from a philosophical side.
So
we're now only working on reachability, and given the net and the current objects, are certain elements reachable? And the question that I have is are those the right questions for verification? And
for that, you'll probably...
I don't have an answer to that question myself yet, but I think there are some problems we want to dive into then, but that requires a new way of thinking.
But what exactly? I mean, could you?
Simple things like if I start with a new object, there are correlations between those. How many instances do I need at least or at most to finish my object before it's deleted?
Yeah, I see. So it's some kind of very tricky type of soundness check. Exactly. Yeah.
And other questions that I then start to have is about communication. So is it, for example, the case that if I want to close or remove one object, I'll always need to create another one? So is it ever possible to finish a case without introducing too many new ones?
Yeah, I see. Yeah, but probably, yeah. No, these are very interesting questions. So I think they are probably relating also to some other works that have been done on simpler classes of Petri nets. I know that well, probably it could be also related, at least from what I know, could be related to this resource-based simulation work that Irina was working on, in which you probably could also guarantee that, well, at least the problem allows you to state that you have probably less resources to be consumed in your net, or I don't know, produced, managed, you name it. So that probably could also be related to the object setting, could be lifted to the object, but I guess I'm just saying now something that is very opportunistic. So probably I could receive some comments on that.
Yeah, food for thought for next week.
Yeah, you're absolutely right. These are extremely important and very good points. I think there was Marco also. Now I see him. Marco?
Yeah. So yeah, Martin. Just to add on top of your question, right? I see quite a separation, so to say, when it comes to these combined models. If you want to go for unbounded study of the net, or if you can, so to say, put some bounds on the number of tokens that you have around. And you see, if you ask me about DBNets or about other data-aware models we have been studying that are more, so to say, case-centric, I would say that there, what is interesting is to study the bounded case, where bounded means bounded in terms of Petri nets, right? You still have unboundedly many data. with these models that are object-centric, the situation is a little bit trickier, right? Because you don't know how many objects you will need in order to complete. And this is clear also if you look into proclets, etc., right? So you have always this unbounded creation, right? Yeah. Now, when in the case where you can bound things, it's also interesting to see what is going on in neighboring communities. So for example, you know that not the results that Andy presented today, but the results for DBNets or for models where we don't have this parameterization, but we just look into one single database that is evolved by the process, right? So there has been quite a lot of research on how to ensure that also you have bounds on the data, right? And some very, very interesting recent works that are based on an idea that I had with Diego on using data models and cardinality constraints to ensure a bound. Have been recently done also in the description logics community, right? So I give you a very rich description logic where you have a full theory of constraints, right? And you also reason under incomplete information. And now you want to know whether if you bound the extension of a predicate, like for example, the order predicate, you will get a bound on other objects that are related to that, right? So for example, if each order has at most 3 items, each item is controlled by a person, right? And a track can contain at most 10 orders. So, you know, you can reason on boundedness just at the structural level. And then you know that the process will never be able to violate these constraints. So it will be confined. Yeah. You see, it's interesting because these questions can propagate to the data component if you have rich constraints, or to the control flow component if you look into the Petri net. So I also don't have a definitive answer on what are the interesting properties, but I just wanted to mention that you see also how to approach these is quite diversified depending on what is the component you want to work on, right? In terms of controlling this.
Yeah, definitely.
I think probably just maybe Marco, like a follow up on what you were saying. The thing that I wanted also to say before that, I guess the harder task would be like Jan-Martijn that you were saying about the number of objects would be to really understand it from the structure of your net. I think this is going to be very hard. However, probably an easier task would be that if you have some extra background knowledge about your domain, from which you could really devise something on the cardinalities that you're manipulating and the amount of objects that could be potentially created. So you can just have this kind of naive safe bound assumed, and based on this bound, you could then just do your reasoning, already considering bounds. Yeah.
Very follow up, right? Just to conclude on that. This also triggers another question, right, Jan-Martijn, on what is part of the model and what not.
Exactly.
So even the more stupid example, you know, like each customer has one cart. Each cart contains items, right? So we all know that if you go to an e-commerce website, there will be for sure somewhere a cap on the amount of items you can add to a single cart, right? I mean, otherwise you could just create a denial of service right to the website by continuing to add items into a cart.
Yeah.
But the point is that usually you don't make this part of the model, right? Because in the model, you just say, look, there is a one-to-many relation between cart and items, right? Yeah. Now you see, when you want to study these systems, there are certain things that you have to move from the implementation details that you're going to add back into the model. So you have to declare, okay, I'm going to study verification when I have one cart that can contain at most 10 items. So you see also what is conceptual and what not is a matter of philosophical investigation here, right?
No, exactly. So this is indeed, so what we said in I'll show more about it next week. But there indeed we said, well, at any point in time, the database will be finite because otherwise you can't store it. So for any information system you have at any point in time, the data model is finite because of physical limitations. And that's why we can have certain elements in the model. But
Yeah.
more on that next week.
Yeah. Even though, Jan Martin, you know, I mean, I think we had a technical discussion on this at Kaiser, right?
Yeah.
So the dividing line for us and for many of these verification results is not really between the finite and the infinite. It's between the bounded and the rest.
Yeah.
So it's because, you know, if you think about even a Turing machine, right? If the Turing machine starts, and now you only consider that the tape of the machine is stored only if the machine ever visited the cell. So the amount of tape that is visited by the Turing machine is always finite, right? Unless obviously it doesn't terminate, then it means that it could run forever and explore an infinite amount of tape. But you see how tricky it is, right? So the dividing line is not just saying, look, I know that I have finitely many elements, so you would need to do finite model reasoning, is to impose really a bound that you know up front, right?
Yep.
Which is more restrictive, obviously, modeling wise. Yeah.
No, completely true.
So more questions, comments? So then I would like to thank Andrei once more for a very interesting talk, and so just which generated so interesting discussion, which is really so just excellent and shows that it's really is interesting for people here. So I hope we'll continue this way in a week. And then Jan Martin will already know what you will speak about. So we will look for this next meeting. Thank you very much to everybody.
Thanks. Thanks a lot.
Thank you. Thank you. Good talk.
Bye, everyone. Bye.
Bye.
Thank you and goodbye.
Goodbye. Bye.